For this problem, we have a set of parametric equations. We'll be eliminating the parameter and graphing the equations. We have x equals 1 plus 3 sine t and y equals 2 cosine t with the restriction 0 is less than or equal to t is less than 2 pi. So we're going to use a little trigonometry trick here, and we're going to isolate the sine t in the first equation and the cosine t in the second equation. When we do, we'll get x minus 1 equals 3 sine t. Dividing both sides by 3, x minus 1 over 3 is equal to sine t. For the second equation, y equals 2 cosine t, we'll divide both sides by 2 and get y over 2 equals cosine t. Now, the trick that I'll be using is the trigonometric identity that says sine squared t plus cosine squared t is equal to 1. But I don't have sine squared t or cosine squared t yet. So what I'm going to do is I'm going to rewrite the two equations. X minus 1 over 3 equals sine t, and also y over 2 is equal to cosine t, and I'm going to take both sides of each equation and square it. Then I'm going to add. When I add on the left-hand side, I'll get x minus 1 over 3 quantity squared plus y over 2 quantity squared is equal to, on the right-hand side, sine of t quantity squared is just sine squared t plus, for cosine t quantity squared, that's just cosine squared t. But notice sine squared t plus cosine squared t is just 1. So now I can identify this equation. On the left-hand side, I'm going to write the x minus 1 in the numerator squared over 3 squared, which is 9. Plus, for my second term, I have y squared in the numerator over 2 squared, which is 4, and that's equal to, we just said, 1. This is the equation with the parameters t eliminated. Notice it's just the equation of an ellipse. Now let's get to graphing this ellipse. So here's the equation. It's already written in standard form. We can see that our center for this ellipse is going to be at h comma k. In this case, it's 1 comma 0. So here's my center. I see that a squared is the larger number and it's under the x squared term. So in this case, a squared is equal to 9, so a is equal to 3. So from my center of 1, 0, I'll go 3 units to the right, and that's my first vertex, and then I'll go 3 units to the left, and that's my second vertex. I can also see that b squared is under my y squared term. B squared is equal to 4, so b is equal to 2. So from my center, I'll go up 2 units to get an end point, and down 2 units to get another end point. Now I'm ready to sketch this ellipse. And here's a sketch of my ellipse. Now, we would also like to use arrows to show the orientation. So what we want to do is get some information using t. So remember, with our given information, we have t, and we have x, which is equal to 1 plus 3 sine t, and we have y, which is equal to 2 cosine t. And let's remind ourselves, we had a restriction. 0 is less than or equal to t, which is less than 2 pi. So we can pick a few values for t in order to get our orientation, put our direction arrows in. Let's start by letting t equal 0. If t equals 0, then x is equal to 1 plus 3 times the sine of 0. Since the sine of 0 is equal to 0, this becomes 1 for the x value. Y is equal to 2 times the cosine of t, or in this case, 2 times the cosine of 0. Since the cosine of 0 equals 1, 2 times 1 is 2. Therefore, we have the point when x is 1, y is 2, and we can put this right here, it is, on our ellipse. This point, 1, 2, corresponds to when t equals 0. Let's pick another value for t now. Let's say, let t equal pi over 2. If we let t equal pi over 2, then x equals 1 plus 3 times the sine of pi over 2. Since the sine of pi over 2 is 1, 1 plus 3 gives us 4. Again, y equals 2 times the cosine of pi over 2. Since the cosine of pi over 2 is 0, 2 times 0 is 0. So our next point on our curve is 4, 0. Right here, it's one of our vertices. This point corresponds to when t is equal to pi over 2. So we can see the direction arrows going in this direction. Next, let's let t equal pi. If we do that, x equals 1 plus 3 times the sine of pi. Since the sine of pi is 0, 1 plus 0 is 1. And y equals 2 times the cosine of pi. Since the cosine of pi is negative 1, 2 times negative 1 is negative 2. So we have the point 1, negative 2. Right here, one of our endpoints. And again, we put in our direction arrow. This corresponds to t equals pi. Let's pick one more value. Let's pick 3 pi over 2. X will equal 1 plus 3 times the sine of 3 pi over 2. Since the sine of 3 pi over 2 is equal to negative 1, this becomes 1 plus 3 times negative 1, or negative 2. And our y value will equal 2 times the cosine of 3 pi over 2. Since the cosine of 3 pi over 2 is equal to 0, this value is 0. So negative 2, 0, it's one of our vertices. We can add our arrows. This corresponds to t equal 3 pi over 2. So with our given equations, we eliminated the parameter and we graphed a plane curve with the arrows for orientation.